So far today we've been talking a lot about equations in vertex form. And our equations in vertex form look like y equals a, our vertical stretch, x minus h, or horizontal shift, squared, plus k. And we call it vertex form because these two values of h and k give us the vertex of the graph. So when we're looking at this equation in vertex form, we can easily locate the vertex, which will be h comma k. That'll be our point. Now standard form we looked at last week when we were talking about factoring. And standard form looks a little bit different. It's still a quadratic, but now we have ax squared plus bx plus c. We don't know the vertex, we don't know the value of h and k, so we cannot sketch it easily. This is a problem because a lot of times we like to be able to sketch it easily. So what we're going to be talking about today is how we can go from something in standard form that looks like this to something in vertex form to quickly find the vertex. So the example we're going to be looking at is our quadratic in this form, y equals x squared plus 12x plus 32. And I'm actually going to change this y to f of x, right? And we've learned that that's really the same thing, function of x, function of f with an input of x. So let's write that as f of x is equal to all of that. Now, what I'm trying to find by the time I finish this equation, the value of h and the value of k so that I can graph this easily. So these are my mystery numbers, and that is what I'm trying to locate. So the first thing we're going to do is we're going to start by factoring this. And if you can think back to last week when we were factoring, when we factor, we start with a box, and then we're going to do a diamond, and we're going to fill in the box with the squared value, the constant value, and the diamond is going to come from the multiplication of the diagonal, and then the middle b value. So we have 32 x squared on the top, and oops, I can erase this. 12x on the bottom. Take a second to factor that. Okay, so you can check your work. Remember we had 8x times 4x, we should get 32x squared. 8x plus 4x gives us 12. We fill that in, and then we fill out our dimensions accordingly. Now we can write our factored form, now that we have this factored. So our final factored form should be these two binomials multiplied together. So f of x then is also equal to h, oops, I'm going to write the x first, x plus 8 times x plus 4. Now, this doesn't help us get a better picture of the graph. So that's really what we want to think about doing. How does factoring it give us a little bit more information about the graphical representation of the picture of the quadratic? One thing we can do, which we practiced, was solving for those x-intercepts. So solving for the roots or the solution of the equation, it's really going to be the place where the parabola crosses the x-axis. So I can even start to just draw a picture of, start with some coordinates, and we're looking for the place where the parabola crosses the x-axis. So to solve for this, I set each of these equations equal to 0. And I'll give you a second to practice solving for x. Now that we have these two values, we can look at our graph and we can put a little dot where approximately we think that value is. And these are where the parabola is going to cross that x-axis. So let me zoom in here. Now we talked about the line of symmetry before on the parabola. So I want you to pause, look at your graph, talk to the people at your group. Where do you think that line of symmetry is going to go in relation to the two x-intercepts? So hopefully you can visualize that that line of symmetry is going to be crossing right through the middle of those two x-intercepts, right through the middle of those two x-intercepts. So talk to the people sitting next to you about how you would find that middle point. So what is the value of x at that point specifically? So one way to do it is to take the average, and when we take the average of those two values, we divide it by 2 since we added 2 points and we get -6. So on our graph, we can go back in and fill this in. So the line of symmetry here is x equals -6. Now, if we think about the fact that the vertex is actually going to fall on that line of symmetry, that means that our h value should be -6. All right, so this is awesome. So this actually gives us the h value. So if we remember what we were looking for in the first place, we needed this h value to be able to graph it. So I can go back in, erase that, and fill this in. My h value is now -6. But we still don't know the k value. We still don't know what y is going to be on the vertex. Since we have one of the points, however, we can start to plug this in and solve. So I could pretty quickly plug in -6 to this equation and solve. All right, we're trying to find for our k, which is really just our y value. We have our x value, -6. So I'm going to plug in to be able to solve that. So now I have function of x with an input of -6, and that's going to equal -6 squared. Have to be careful with my parentheses when I square a negative number. 12 times -6 plus 32. Take a second to simplify that. And so we get f of -6 equals 4, which means really that our k equals -4. Sorry, -4, not +4. And when I go to plot this point now, k equals -4, h equals -6. I find it on my graph. -6, -4. And now I can sketch my quadratic. I can also go back in and plug in these two values. To find my final equation in vertex form. And if I simplified that, 2 negatives would go and make a positive. So that is my final equation in simplified vertex form.